Hello everyone, welcome again to my channel and Recursion with DP Memo video. So here we'll solve another problem, that is 139 word break, and it is quite a famous problem, and it has another problem called word break 2. So here for this word break problem we will use recursion with DP memorize technique, which we solved in the previous problem where we used it in minimum cost problem. So the problem statement is saying, given a string S and a dictionary of strings word dictionary, return true if S can be segmented into a space separated sequence of one or more dictionary words. Notice that the same word in the dictionary may be reused multiple times in the segmentation. So what basically it is saying is, you will be given with one string, say Leetcode, and another word dictionary or collection of words, you can say, that is Leet code, like that. You have to tell this word you can form using this word of dictionary or not. Any word you can use multiple times, and if you concatenate those things, then you can form this word yes or not. That you have to return like true or false. Here if you check, leet code you can form easily by just appending leet with code. Then it will be a true. If you take another example, apple, pen, apple, and the word dictionary is apple and pen. Here also it is possible because apple you can take twice, means apple, then pen, then apple. So you can make use of this dictionary words and form this string. So here also it is true. Here we'll check another example, cats and dog. So the word dictionary contains the words cats, dog, sand, and cat. If you check here, cats you can get here, then the remaining part will be and, that also you can get here, but OG is not present here. So if you get dog also, then also it is not matching. So no way you can form this word using this dictionary words. So in this case it will be false. Though it looks like that these words are present here, but if you look carefully, if you add them or concatenate them, you never can form this string word. And here is few constraint, that the string length will be 1 to 300 and the dictionary length will be 1000, means 1000 words can contain, and the word dictionary length will be 20, means one single word can be of length 20. So these are, and all letters will be in lowercase, and all the strings in the dictionary will be unique, means no repetition. Now to solve this kind of problem, why it is a bit hard is because you don't know like that what part of the string you will cut and then append the other part, because cats also you can cut from here, or cat also you can cut from here, and after that whatever decision you will take, then the remaining part you have to check and match with the other words. So it's a step by step decision what you can do. So now we will check in this case how recursion will help us and how we can optimize this problem using DP memorization technique. So here we will take our first example and apply recursion to check how we can solve this kind of problem. So the string is cats and dog, and the word dictionary is cats, dog, sand, and cat. So as I have mentioned in the earlier videos of recursion or backtracking, that in recursion or backtracking kind of problem, you have to first think as a normal human being that what are the steps we can take and what are the decision I am taking, and based on that how I can growing. Suppose if I have to think normally, then what we can do? Cats and dog, one string is present. First I have to match that the first part or the prefix part, because anyhow if I have to form this string, then initial prefix also will match with some of the word, right? Then we have to think about other part. So our first job is to find if any of these words matches with the prefix. So here I got that cats can be a match, or cat can also be a match, right? Because both can match as a prefix in this word. So that is the two decisions we have to take. Once if I am taking cats, then what is the remaining string? That is and dog. Okay. Another decision is if I am taking cat, then the remaining string is sand dog. Cool. Now we have to proceed again and apply the same logic for the remaining part also. For and dog, I have to match the prefix. Here, what part will we match? And will match only. That means if I match with and, then the remaining part will be OG. Okay. And as in the recursion call, we will go as DFS manner. First, we have to complete one single substring, and then we have to return back and check the other possibilities. So actually, if we start from cats and dog, first when we are matching with cats and growing this part of the tree, first I have to complete this part. But to train our mind, I just shown that the next part of the job will be with the sand dog. Okay. So after and dog, when I got that and is matching, the remaining part is OG. From here, if we have to go forward, then we have to match that for OG, is there any prefix matching or not? But unfortunately, nothing match we found here. That means this path we can't proceed and this path is returning false. Means if we go like that, we can't get a match. Then you have to check for the other possibilities. So from here also nothing matched apart from and, so we have to return back and check from sand dog how we can proceed. For sand dog, what is the matching prefix here? Sand is a matching, right? Because this part we can match. Then after that, what will be the remaining string? Again, it's OG. That means here we can't form the string cats and dog using this word dictionary because we run with all the choices but not got a correct result. Let's try with another example. Here the string is apple, pen, apple, and the word dictionary is apple and pen. Here also we will run with our choices. So first we will match one prefix from this word dictionary. So the first match is apple. Okay. So if we match with apple, then the remaining string will be this pen apple. Pen apple. Now we have to check with pen apple something is matching or not as a prefix. Yes, pen is matching. Then what is the remaining string? That is apple. And now we have to check if something is matching with apple or not. Yes, it is matching the prefix. Then we are done, means it is true. We can form this string. So if after that my string will become empty, right? A empty string. Empty means I have consumed all the word dictionary to form the string. So if I go via this path and we are done. So it's a true. So if we have a very long word and a long series of word dictionary and if we keep on drawing the decision tree, things will be like more example or more cases we can handle and we can see. But I think you understood, right? So how we can solve this? And as we have to return true and false, or you can say we just want to check that it is possible or not, that means if any of the tree you can get true, you have to just break out. So if someone is saying that how many less word you can use to form this and all, that is a different question. Then you have to compare between all the paths. But here they just want to know that it's a true or false. So if you find somewhere, stop there and return true, our job is done. Now the question is why I told that along with this we have to use DP memoization also, where that thing can come into the picture. That I will discuss now. So now where DP will come into the picture. Let's say we have a very big word and when we are breaking them down, we found that word OG. Okay. And suppose after breaking down OG or take some paths, we got to know that we can't proceed with OG and OG will return us false. That time, if I again get OG somewhere, we no need to proceed further with our choices. So one table we can form, there all the substrings when I am going, I can make a note that for OG it will be false, or say for sandog something and something and all. So next time when I'll get OG, I will check what is the value present there. If it is false, that means no need to proceed in this path. It will give me result as false. So think about a very big decision tree. So there, if we take help of this DP memoization table, then so many calls we can reduce, right? So here we don't have to go deeper. Maybe somewhere else also we can find a string where already I have a calculated result in this DP table and I don't have to go further. We can directly pick the table from the, say, hash map or something, right? So that is the advantage you will get if we have a big tree. So that's why this kind of problem is of recursion with DP. Now we will go jump into the coding and I will understand this thing better. Now I will code this part, how we can do the coding. So this word break method is whatever it is passing is one string s and a list of string which is word dictionary. So I will repeat this method as a recursion call. And what will be the base condition for that? So if we reach to the end, say our s dot length equal to 0, then we'll return true. Means if you remember from the diagram, so every step we will reduce the string after matching the prefix part. So at the end, if it is 0 means everything got matched, that time we'll return true, and that will be the base condition for this recursion call. If that is not there, means string s has some length, so what we can do is we will try to find that if any prefix is present in the dictionary or not. So for that purpose, we will iterate over the dictionary word dict, okay, and we will check that if any matching prefix is present or not. But first we can do a check here that if this str.length means the word length is greater than the string length, that means there is no prefix possible, right? So that time we'll just continue. Means if this apple itself is bigger than this word length, then it will not be a prefix of that thing, right? So that's why I'm continuing. So now we can take a variable called boolean result, which I have to check that it is what it is returning. So if this string s starts with, means it's a prefix of string like str is a prefix of string s, that time I have to check what is the remaining string, because that I have to pass to the next recursion call. So that will be substring like s dot substring of from str dot length, means after cutting the str whatever is remaining. So our result will collect from the recursion call. Say result will be again this word break we have to call, and here I have to pass this suffix and word dict. Okay. So next time my word will be the suffix because prefix already matched. And here if we get that for that call, if this result equal to true, that time we have to return true, or else after end of this loop we can simply say nothing matched and we can return false. So now if we run this problem, so this is working, right? So if we submit now, the solution is perfect, but it is time limit exceeded because we have done things correctly, but we have not used DP memoization technique. That's why it is going through all the recursive calls, right? But the expectation is we should use DP memoization technique to reduce the calls. So now what improvement we can do is we can define a map, hash map of type string and boolean. Okay. So where we can store like suffix string and the result what we got from the previous recursion calls. So now if we have to look up into this map, say memo, if it contains this string key, okay, this, so it will be contains this string key s, then we have to return the result from the memo map, which will be s. Okay, and how we can store this result here? So whenever I am getting the result here, that we can store memo.put I have to do, and there it will be suffix and result. Now if we run this problem, it is working here, and now we will submit also, and it is working. So this is the way we have to solve it using recursion and DP memoization technique. Thanks for watching.